Welcome guys, this is going to be 3.1 and in 3.1 we are going to dive into the world of inequalities. In fact, that's what chapter 3 is all about, as you probably could have guessed by the screen. So chapter 3, specifically 3.1, we're going to look into inequalities. And what is an inequality? It is something that is not equal. Now, what does this mean for us mathematically? We're not talking about wealth inequality or anything like that. Rather, we're talking about a set of numbers making a statement true. Typically, our solutions are going to be a set of numbers as opposed to one specific number. In chapter 2, if you remember, we were solving algebraic equations and we often got x equals 1 or x equals -4. In chapter 3 with the inequalities, it's going to be more x is greater than or equal to 7. So naturally, there are more numbers that can fit into x than just one. Thus, we typically will have a set of numbers for our solution. Now, we can review the symbols really quick. Again, these are the different symbols we will use for our inequalities. And the big thing to note, I can pause it right now if you've never seen these symbols and want to write them down. If they review, you don't have to. But the big thing we can do to start reviewing is look at the inequality x is less than or equal to 7. X is less than or equal to 7. How do I know which side is the smaller side? Well, the open side of the inequality will always indicate what is larger. Okay, so if I have the two inequalities here in black, well, we would read the top one as all numbers are less than 7 make the inequality true. Thus, x, which stands for a number we don't know yet, is less than or equal to 7. Consequently, the opposite would be the bottom one. This indicates that any number greater than 7 will make the inequality true, and thus we read it as x is greater than or equal to 7. Again, x standing for a number we do not know yet. So how could we apply this? Well, one of the things we could look at is if I have this inequality and I give you 3 options, 9, -1, and 14/2, I want you to pause the video right now and circle or on your own piece of paper, write down which one makes the inequality true or ones make the inequality true and which one or ones do not. Okay, let's talk about it. Again, this is probably review for you. When you see x is less than or equal to 7, the open side of that inequality is facing the number, which means the closed side is facing the variable, meaning that anything going into the variable has to be less than or equal to 7. So when I look at my options here, 9 is not less than or equal to 7, so it will not work. -1 is less than or equal to 7, so it will work. And finally, 14/2. 14 divided by 2 is 7. So will it work? Yes, because of my line underneath. Again, the line underneath the inequality being in equal to. Again, I'm sure this is familiar with you or for you. If it is not, please let me know so I can help catch you up. Okay, so now where we are going to jump into is look at some examples of number lines. Now, when you learned inequalities for the first time, you learn not only how to look at them and what numbers did and didn't work, but you graph them, so to speak, and you graph them on these number lines. Again, probably review for you. We'll use the inequality x is greater than or equal to 4. I have the inequality x is greater than or equal to 4, and I would like to plot it on the number line. There are 3 key steps to plotting it. Number 1, what we want to do is we want to go ahead and place a circle at our point of interest. What's our point of interest? The number. The number is, or the constant is going to be our point of interest. From there, we determine which way our arrow should go. How do we figure that out? Well, if the open side is facing the variable, like it is in this case, It is a form of greater than, right? X is larger than 4. So any number greater than 4 satisfies the inequality. Again, I know this because the open side is facing the X. Well, where are all the numbers greater than 4? To the right of 4. Okay, to the right of 4. So I'm going to draw an arrow in that direction because any number larger than 4 will make this true. The last step, I have to look at the inequality symbol itself. If there is not a line underneath, I will leave the symbol or the circle open. But if there is, I will close the circle. Why will I close the circle? Because equal to is what the line underneath the inequality indicates. And that means that 4 does count as one of those numbers that make the inequality true. So again, your review for making number lines. Step 1, identify your point of interest. That is going to be your number. Number 2, what you need to do, you need to figure out which way the arrow goes. Does the arrow go to the right or to the left? Again, little examples of that is if the open side faces the variable versus the closed side facing the variable. And finally, you need to determine whether to fill in the circle. Do we fill in the circle or not? And again, that is based on whether there is an equal to sign or not. So given these steps, what I would like you to do is I will write the inequality x is less than 2 here. What I would like you to do is create a number line for it. So pause the video and create your number line. Okay, so your number line is created. Let's check your work. Now, some of you may be wondering, well, how many lines should be on my number line? Mine looks a little different than yours. As long as you have a minimum of 5, I'm okay with it. So you're making your number line here. Identify your point of interest. That's step 1. What point am I interested in? 2. 2 is my point of interest. That is the number being compared to the variable. From there, I need to figure out which way my arrow goes. The closed side of the inequality is facing my variable, and the open side is facing the number, which means all numbers less than 2 make the inequality true. Therefore, my arrow will point to the left. Finally, I need to determine whether I fill in the circle or not. Well, I look at that, and there is no equal to sign, so I need to not fill in the circle, which means I need to have an open circle around 2. Since the 2 itself would not make the inequality true, since it's strictly greater than or less than. Okay? Now let's back up a hair, and I want you to go the opposite way. I want you to, on your piece of paper, create a number line and draw, or rather, I'm going to give you the number line. I need you to identify the inequality that I've created here. I'm actually going to make 2 of them. Okay, so pause the video and identify the inequalities I have made. Okay, so hopefully you unpause the video. You've figured out what to do. For my green one, I need to identify the point of interest. That point of interest is -1. Now, I need to identify which way the open side of my inequality should go. Well, my line is going to the right, which means it's all numbers larger than -1. So if I am having all numbers larger than -1, the open side of my inequality should face the x. And then finally, do I fill in the circle or not? Well, the circle is not filled in, which means that this is a strictly greater than or less than. Let's talk through the same logic for my red number line inequality. So my point of interest is 3. Point of interest is 3. The inequality is shooting off to the left, which means that the open side of the inequality needs to face the number. And finally, the circle is filled in, so I will use a greater than or equal to sign underneath. Now, please note, when you look at the inequalities I have written, you might have written yours a little differently. What do I mean by that? I mean, you might have written 3 is greater than or equal to x. Or you may have written x is greater than -1. What I hope you recognize is that they mean the same thing. I don't care which way you write it. What I care about is you need to make sure the open side faces the larger quantity. What do I mean? When you look at the red arrow shooting off to the left, 3 is the cutoff. It's the largest point that's going to get. Therefore, the open side needs to face the 3. Whereas in my other example, -1 is the smallest point. And then we shoot off to infinity in the right, which means the unknown variable is larger. Therefore, the open side should face the variable, not the point of interest or the number. Okay? So please note, I don't care about which way you write it. What I care about is that the open side is facing the correct quantity, either the number or the variable. Finally, let's jump into some real world examples. Okay? So I have 2 situations here. I have 2 signs. I've got a speed limit sign here on the right, and I've got a minimum wage sign here on the left. What I want you to do is I want you to write an inequality for each situation described. So pause the video and write an inequality. Okay, so you've written your inequality at this point. What I hope you came up with for our sign on the right is the speed limit is 25. Your point of interest is 25. And what I hope you have is that your open side of your inequality is facing 25. Why is it facing 25? Because we can't exceed it. We can't exceed 25, so the open side should face the 25. Then you should underline it because you can go the speed limit and still be legal. As we're looking at the other one here on the left, your point of interest is 725. Now the opposite is true here. The open side should face the x. Why? Because a minimum is what 725 is. It is the minimum amount you can be paid. You can be paid larger than that, but legally you are not supposed to be paid less. Can we underline it? Absolutely. You are legally allowed to make 725. Now, you see, this is a hair dated. The federal minimum wage has increased some, I believe. That is from 2009, but the point still stands. So hopefully this is review and makes sense. Again, let me know if you have questions.